Welcome to Module 28 in this series of lectures on statistical process improvement and statistical quality assurance. We're going to take a bit of a digression in this module. We've been talking about Short control charting or statistical process monitoring. We'll come back to that in the next few modules, but this particular lecture concerns clarifying the relationship between statistical process monitoring and what we're going to call EFC, or engineering feedback control. When we introduced statistical process monitoring, we tried to emphasize that it is about process watching for purposes of change detection. That is, it's a monitoring methodology. When there is change detected, exactly what to do about that change is not specified. It's a methodology for saying something's different here, and it's time to go make a physical investigation. Engineering feedback control is a technology where a physical process has some input or input variables, or what one might call knobs on the process that can be turned. And depending upon where those knobs are set and what's going, and all sorts of details about what's going on, out of that process comes some kind of a measurement. That measurement is fed into a control algorithm together with a target for Y, and that produces an adjustment or a prescription for how to change X. This is a ongoing compensation process tweaking methodology. It's not the same as statistical process monitoring, and it shouldn't be confused with statistical process monitoring. Statistical process monitoring in particular is not a form of engineering feedback control. These are not competing technologies. They both have their places. They both can be well done or badly done. They both can contribute to variation reduction. Neither is a weak version or of the other, and it is pointless to try to argue about which is more important. They're simply different technologies. Here are some contrasts between the two. Engineering feedback control is typically automated. It's either digital or mechanical. It's oriented towards making compensation. It expects a process to drift and basically is there to correct for drift. It is more or less ongoing process tweaking. It is typically computer control. It tries to maintain an optimal adjustment of a process. In some sense, it is tactical. It is right at the level of machines and what's going on, and it's sort of narrow focus technology. In addition to that, it uses dynamic models and often some fairly substantial mathematics to basically decide what's an appropriate algorithm to put in that box there. Statistical process monitoring is often almost manual. There's probably not many applications these days where pencil and paper are used, but it doesn't have a black box flavor. It's something where as data are taken, people are looking at the data or plots of the data. It is detection oriented, that is, it's aimed at detecting change. It expects, in some sense, that a process is stable, that it's not drifting, but that uh, that it is consistent within the limits of ordinary random variation. It doesn't prescribe tweaks to a process, but rather it uh, sounds alarms that are intended to uh, send someone to have a look at a process, make some kind of undisclosed or unspecified intervention. Statistical process monitoring alerts a human agent. It warns of special cause changes. And in contrast to engineering feedback control, it's more strategic. It's not so much down at, well, it's often not so much down at nitty gritty of exactly how should I adjust a a tool on a lathe, but it's warning that something has gone wrong, and it warns of departures from stability. These are different technologies. EFC deals in feedback algorithms. Statistical process monitoring deals in control charts. There's a nice example in the Vardaman and Job book that had to do with control of a paper making machine. Paper making is actually pretty simple. It's a pretty simple process. Pulp is pumped out onto a conveyor belt, and as the pulp moves down the conveyor belt and heat is applied over the length of the conveyor belt, the pulp dries and makes paper, and then it's weighed at the end of the conveyor belt. If there is a target weight for the paper, then it's possible that a weight sensor sends that information to some kind of an algorithm that adjusts a pump speed, that adjusts how fast how fast pulp is pumped onto the moving conveyor. Issues in developing an appropriate control algorithm for that kind of a process include at least the following. The pulp mix thickness varies. There's, despite all intents of stirring the tank up and keeping the water mixed in with the pulp, as time goes on, this stuff that's pumped onto the conveyor belt tends to get heavier, gets more dense, but pump speed can be changed to compensate then for how much material is going on to the conveyor belt. This is an SPC. This is not an SPC problem. It's an automatic compensation problem. The particular application discussed in the Vardaman and Job book had a constant density target for the paper of 70 grams per square meter. Experience with the process said that changing the pump dial by one tick changes the density of the paper on the order of 0.3 of a gram per tick. A particularly difficult issue here is the fact that there was about a 4-minute delay between the 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 introduction of the pulp onto the conveyor belt and when the paper was weighed, and so any change that is ordered over here only affects paper that is going to get to the weight sensor 4 minutes later, and that time delay has the difficulty of creating the potential for overcompensation if I don't take account of it. As it turns out, the discussion in Vardaman and Job showed that through a series of experiments, a particular kind of control algorithm was developed, and this was the result. Here are data for, or here's a plot of data for an uncontrolled process, just where one simply turned the process on and let it run. And you can see that there's trend here. There's one is not hitting that 70 target for the density of the paper. This is what happens if one doesn't tweak the process. Using a fairly smart algorithm that was developed in an experimental work with the process, instead, this is what's possible. If one does wise process adjustment, one can keep the density of the paper right at the 70 grams per square meter target figure. This is an example of how engineering feedback control can improve a process and reduce process variation. To this point, there's nothing about this that has to do with control charting. But now, with this being what's expected, one might set up a Shewhart control chart on the output of this process and monitor for the unexpected things like a clog in the feeding mechanism, or just some kind of effect of a change in raw material. That is, to this point, it's an EFC story. Statistical process monitoring only takes over now at this point.